All right, I think we're ready to kick things off. All right, thanks for joining. So this evening we're going to pretty much finish the last of the content for this course. We're finishing up Learning Unit 9. And I think for the sessions that for the remaining weeks we'll just do some revision. So let me begin. I don't think this will, take the full hour, but even if it does, it's fine. Let me share my screen and tell you what the content is all about today. All right, so I am sharing my screen, but just let me know otherwise. Okay, so before you read through this question, let me talk about what the chi-squared goodness of fit is. Okay, so to kind of explain it, and we do use this, in the real world, it's quite important. So let me give you an example. So I'm going to draw a bar graph, but the bar graph is going to be a stacked bar graph, but I'll explain what that is exactly in a second. So here, right. So now let's say we have a variable that just captures the percentage of people that pay by a certain time. So in other words, this variable, we'll call it payment method. We'll call this variable payment method. And it can take on 3 values. Okay, so it can take on cash, so people that pay by cash, right, which is kind of reduced in these days because most of us will pay by card. So you can either pay by cash, you can pay by debit card, and credit card. We'll just keep it as, okay, no, let's just leave it at 2 for now, right? Let's just leave it at 2. And as you know, in this day and age, we have more than just these 2 ways of paying. You could use Zappa. There's a whole bunch of ways. You can use your cell phone app to pay. So there's a variety of methods in which you can pay for things now, right? But let's just assume it can only be cash and debit card. Now, in the year, let's say year 2005, right? And now, let's just say this is where we are now, and 2005. On this y-axis is the percentage of people that pay by these methods. So in other words, if I draw this bar graph here in 2005, right? I'm going to draw 2 bars here. They're kind of the same size. So let's just say it's almost, these bars are almost the same size. Now, the bar in green is the percentage of people that pay by cash. So the green is cash. I'll write it here, green. And the blue is debit card. Okay, hypothetically, let's just assume these are the only 2 ways that people paid. Then in 2005, and now let's look at what it sits at now. So now, as you could expect, there's less people paying by cash. So that green box is a lot smaller now. So let's just say this is what it is now. This is the percentage of people that pay by debit card, and then the percentage of people that pay by cash is a lot less. So now this is the green block. Right, so altogether this makes up 100%. 100%. So this is the percent frequency. All right, so yeah, this is the total of 100. And you can see that the percentage of people that pay by cash now is quite different. So what we're saying is that the distribution of payment methods have changed. And you can see this visually, okay? Like you can see there's a significant difference just by looking at it by eye. However, sometimes in practice, that's not good enough to just rely on, visual confirmation. Like you may say, no, it is a bit different, but I wouldn't say it's significantly different. And how do you define what's significant becomes subjective, right? One person will have one opinion and another person will have another. So we need to find a way that's definitive and that everyone can agree upon in order to determine if the distribution has changed or if it has remained the same. And that's what the chi-squared goodness of fit test is. It's a statistical test that has data to back it up. Okay, so it doesn't just rely on people's opinion. And this can be quite important, like in the real world. Like if these variables, like such as payment methods, they feed into models, and these models make predictions. Now, this distribution of this variable changes that can affect how this model performs. And an example of a model is, think of when you go to a bank and you apply for a loan, the bank will assign a probability that you pay them back. Now that probability comes from a model, and it's variables like this: payment method, your age group. I could give you. Oh, I can't think of anything else offhand. Oh, the amount of credit you have on different types of products, like your home loan, revolving credit card, etc. It's important that the distribution of these variables remains the same. And if it changes, that can affect the performance of the scorecard or the model. In other words, that gives you a probability that you will default. Okay, so this whole thing that I just took you through, that's just to kind of give you context of what the goodness of a test is, what it does, and how it's actually used in the real world. Let me just erase this. I'll come back to the chat and see if there's any questions. Okay, let me just check the chat. Good. Exam brief. Leanne, what you do? I think your lead OT would take a support session that would have that. Once I hear about anything, then I will let you know. All right, so let me get back to the whiteboard, and now we're going to apply this the chi-squared goodness of fit test to this problem. Okay, so let's have a read through it. A financial officer of an electronics goods company that sells TVs, sound system, DVDs, VCRs, etc. As you can imagine, this is quite an old problem because a lot of these electronics are kind of outdated now. Okay, so the financial officer knows from past experience that 23%, I'm going to underline this because we're going to use this later, 23% of the store's customers pay by cash. Okay. 35% use debit cards, and the remaining customers pay using credit cards. 42% use credit cards. Right. Now he wants to confirm that this is still the same payment method for electronic goods purchases. So what this financial officer has done is this officer has taken a sample of 200 sales receipts, taken a sample of 200 sales receipts and put this frequency table together here. So what you have in this table is you have 200 people or 200 customers, 41 of whom are paid by cash, 49 are paid by debit card, and 110 are paid by credit card. So most of them are paid by credit card. And we want to test to see if the distribution has changed from what was stated in the question. So is it still 23% that pay by cash? Is it still 35% that pay by debit cards and 42% by credit cards? All right, so we're going to test that. And that's what this question is asking us to do. Use the chi-squared goodness of fit test to determine whether the payment patterns of the past are still relevant today, and there's a level of significance. Okay, so just like before, there's 5 steps to the hypothesis test, right? Step 1 is to state your hypothesis. Okay, so step 1, state your H0 and H0 and H1. All right, so H0. Now your H0 will always be that the distribution is the same. Now don't just say the distribution is the same. You need to refer to what the question is asking. The distribution of what exactly? And in this question, we're looking at the distribution of payment methods. So your H0 will always be that the distribution is the same. So we're going to say the payment distribution is the same. Okay. All right. H1, you don't have to write a long explanation. Since you've already provided that for H0, you just need to say for H1, the distribution has changed. Okay. Has changed. And that's step one done. You don't need to say whether it's a two-tailed test because for chi-squared tests, as I said in the previous session, it's always an upper tail test. All right. So let's move to step two. Step two is to find the rejection region. All right. So let's draw the chi-square graph. Let's sketch it here. Okay, so from the last session, you'll remember that it's a skewed distribution like this, and it drags out to the right like that. So I may not have drawn it like how it is in your textbook, but I'll put that image here in a second. Okay, so your rejection region is on the right. Okay, we need to find this value here. That's the cutoff. Now this area is given by our alpha. Okay, so from last week's session, remember the size of that rejection region, the area is given by your alpha or your level of significance. In other words, here, the size of this region is 0.05. That's your alpha. Okay. All right, so now let's just find this value that corresponds to an area of 0.05. Now I'm going to copy the, we have this diagram in the back of your book. I'm just going to put it here on the board so you can refer to it. All right, so the graph that you see that I've just pasted is the same as what I've kind of sketched on the top. All right, back. Okay, cool. Nice. Now, if you look at this graph, the alphas are given by the first row. So our alpha is 0.05, so that's the second column. Now we need to determine which row. And in order to determine which row, we need to calculate the degrees of freedom. Now for the chi-squared goodness of fit test, the degrees of freedom is calculated differently to how we've been doing it before. It's just for the goodness of fit test that it's done differently. The formula for that is this here. It's df degrees of freedom equals to k minus m minus 1. And I'll explain what the k and the m are. Now, the k is the number of classes that you have. Now, if you look at your problem or the data that's given to you, there are 3 classes or categories: cash, debit card, and credit card. There's 3 of them. So that's why your k is 3, because there's 3 categories. Now, your m, unless the question tells you it's a normal distribution or to test whether it's a binomial distribution or Poisson, if it specifies a specific statistical distribution, then your m is going to have a value. Otherwise, if it doesn't say that, your m is 0. Okay? So if you want me to summarize that, your textbook, all right, on page 305 will have this table here. I'll paste it in the whiteboard. Okay, so I'm going to paste it here. Okay, so it's on page 305, all right, and it has this table here. Now, what this table, you have to unfortunately remember this, okay? If they're telling you to test whether the distribution is a normal distribution, then your m is going to be 2, as shown in this table. If you're testing whether it's a binomial distribution, your m is 1. If you're testing whether it's a Poisson distribution, your m is 1. Otherwise, it's always 0. So in our case, if you read the question, There is no mention of a normal distribution, no mention of a binomial or a Poisson distribution. That's why your M is 0. So now you know your K, you know your M, and if you substitute those values into that equation, then your DF will be 2. So 3 minus 0 minus 1, which gives you 2. I'll write that here. So now we know it's this column, because that's your alpha, .05. The row will be where DF is 2, as we just worked out here. So it's this row here. So where they intersect is here, 5.991. All right. So where if you travel along the row and a column, there's your chi-squared value, your critical value, which is 5.991. So anything above that, we reject H0. Otherwise, we accept H0. That's all. Let's put it in a different color. Anything less than 5.991, we will accept H0. Okay, and that is your step 2 done. Let me just check the chat. Any questions? Good. All right, let's go back to the board. All right, so now I'm just going to clear this table because this graph on the bottom, because we don't need that now. We've done step 1, we've done step 2, let's move on to step 3. Step 3 is the bulk of your workings. Okay, it's where you'll get awarded the most amount of marks for this question. So it's very important you understand the steps, and I'll take you through it now in more detail. So I just need to make some space. Okay, now let's move to step 3. Step 3, calculate. Oops. Step 3 is to calculate your chi-squared test value. So you have to calculate this value here. Now the formula for that is sum F0 minus FE all squared divided by FE. How we do this, how we work out the value using this equation is we construct that table that we did like we did last week. So in other words, what we're going to do is we're going to create a table, all right, with our 3 categories: cash. We have cash. I'm just going to put C for cash, debit card DC, and credit card is CC. All right. Now, let me make it a bit larger. Sorry, space. So CC, DC for debit card, and cash. All right. Now we have our observed frequencies, your F0. Your F0 is just what you've observed from your data, and that's these values here. So your F0 for cash is 41. That's the frequency of how many people you counted who paid by cash. For DC, it's 49. And for CC, it's 110. Right? So the total, if you add all those numbers up, it's 200. Okay. Now, we know what the expected percent is. Okay. Because if you read the question, it tells you that the officer knows from past experience. So in other words, past experience, it's what they expect the percentage to be. So these are the expected percentages. So this is your FE, but in terms of a percent. FE, but it's a percent. Okay, so your percent here for cash is 23%. Right? For debit cards, it's 35%. And for credit cards, it's 42%. Right? That's the expected frequency. All right. We need to calculate what is the number that's expected. We don't want the percent. We want the actual number. So if you had 200 people, and you expect 23% of them to pay by cash, then the number that you expect to pay by cash is simply 23% times 200. That gives you 46. Does everyone understand that? Because if you expect 23, no matter how many customers you have, let's say you had 100 customers, and if you expected 23% of them to pay by cash, then you would expect 23% times 100 people, which is 23 people to pay by cash. So check the chat there. Okay, I assume everything's good, but just let me know otherwise. So in the same way, if you expect 35% to pay by debit card, then 35% times 200 is what you're going to get for your expected frequency for debit card. All right, so the value there is 70. And in the same way, it'll be 42% times 200 for credit card, which is 84. All right, so now you've got your expected frequency. All right, now let's clear this. So we've got our F0, we've got our FE. So if you look at what we need in this equation, in this formula, we have the values. We have everything we need. We have F0, we have FE, and we have FE again. So we have those two ones. So now we just simply work out what's in this equation here, this block. And we can just construct more columns to make it easier to do that, just like how we did last week. Okay, so I'm going to launch it here. So in this column, all I'm going to do is I'm going to work out the numerator. Okay, so here in this column, it's going to be F0 minus FE all squared. Now you could do the whole thing. You could do the numerator and the denominator in one step. Okay, but I'm breaking it up. Okay, it's up to you, but I'm breaking it up just because it's easier to follow, and you know, it might make it reduce the chance of making a mistake. Okay, so F0 minus FE all squared. So what does that mean? That means you subtract the two. That means your F0 for the first row is 41. And then you subtract FE from it, which is 46. And then you square it. All right, if you work that out in your calculator, that'll be 25. You do the same thing for the next two rows, the debit card and credit card. If you do that, you get 441 here. And in the last row, you get 676. Okay, doing the same approach that I've done here for the next two rows. Okay, so now you've got your numerator. Now the last step is just to divide that by FE. Okay, because if you look at that equation here, this whole equation, the numerator is what I worked out in this column here. So the final value is I need to take what I have in the numerator and then divide by FE. So the last column is going to be everything, F0 minus FE all squared divided by FE. And all you have to do here is simply just take the values you have in this column and divide by this column, FE. So this first value here, simply just 25 divided by 46. All right, so if you do that, you get 0.543, 0.543. All right, you do that for the next row and you get 6.3. And lastly, the final value is 8.048. And that's it. You've done pretty much all the workings. The last thing you got to do is remember the sign here is that you're summing it all up. That's what the sign means, summation. So it means you add up all the values in this last column. If you do that, that will give you your chi-square stat. So I'm going to write that in a different color. So if you add up all the values in the last column, 0.543 plus 6.3 plus 8.048, you get a value of 14.891. So 14.891. So that is your chi-square test value. So based on this, do you accept or reject H0? Look at where your critical value is. Your critical value is 5.991. And our chi-square test is 14.89. So is it bigger than 5.9? Because if it is, then that means it's falling in the rejection region. If it's smaller than it, then it means it's on the left of it, and it's on the acceptance region. So based on that result, do we accept H0 or do we reject H0? What do you think? Let me give me the answer. Just want to make sure that you kind of understand the interpretation here. I'll go back to the board. We've got a chi-square test value of 14.891, but our critical region is anything above 5.9, we reject H0. So if you go and look at chi-square test and see where does it lie, on the right of 5.9 or on the left, and if so, do we reject or accept H0? Very good. That's exactly it. Yep, we reject H0 because 14 is much bigger than 5.9, so it's definitely sitting here in the rejection region. All right, and that's your step 4. You've just done step 4. You reject H0. Okay, so we reject H0. So just step 4, we reject H0, so we'll put an X here. Step 4, we reject H0. So that means we believe H1. And so all we have to do now is write it in words. So step 5 is just writing it in words. And we always start with our level of significance. So something you could say is at a 5% level of significance, right? The distribution or the payment distribution has changed. And that's it. You have answered the question. That's all 5 steps. And this question can easily carry at least 10 marks. Okay, does everything make sense here that I've just covered? Anything you're not sure about? That is the chi-squared goodness of fit test. I'll leave the floor open to you. Thanks, Clinton. All right. Thanks. Thank you. Thanks, Jenna. All right, then if you don't have any questions, look, even if you do have any questions later on, just drop me a mail. But yeah, that brings us to the end of the course content. And from now on, it will just be revision. So yeah, I wish all of you the best. Yeah, and all the best with your revision and your studies for this course. We will chat soon. If you have any questions, please email me. But yeah, I will stay in touch. And thanks for joining this evening. Have a good evening.